Hi, this is Mrs. Thomas's Common Core Math videos. Today we're talking about fractions. We're going to use prime factorization to get a better understanding of fractions and how to simplify them. Okay, if we're going to use prime factorization to simplify fractions, we need to know what prime factorization is. So the word factor is just two quantities being multiplied together. They can be fractions, they can be numbers. So what we're doing is we're taking a number, let's say 36, and we're finding factors. So we're finding numbers that multiply to 36, but we're not going to list all the factors that multiply to 36 because really we're interested in the primes. A lot of numbers have a lot of different factors, but the prime factors of a number is almost like its fingerprint. It's unique to that number. And it's really useful and important to know what factors that number is made up of. You can almost think of the number as a molecule and the factors as the atoms. And once you know what factors are in a number, you know something about it that's going to be useful later on. So let's say we have 36. We're trying to factor it. So we're going to just pick two numbers that multiply to 36. I'm going to pick 6 and 6. Okay? So these are factors, but they're not prime numbers. Prime numbers are numbers that can't be broken down any further. The only numbers that multiply to a prime number is 1 in itself. 6 can be broken into two factors that are not 1 and 6, 2 and 3. 2 times 3 is 6. 2 is one of those primes. 2 cannot be broken down into any factors other than 2 and 1. So it is done. That's a prime number. 3 is a prime number. So this 6 also is 2 times 3. So the prime factorization of 36 is 2 times 2 times 3 times 3. Always. No matter what order, if I have these four factors, then I know I have a 36. And when I have a 36, I can think this is made up of all factors of 2 and 3, and that helps me when I'm simplifying fractions. All right, let's talk about some prime factorization tricks. You want to find those factors, and the factors sometimes leave fingerprints or clues on the actual number. You probably already know that if a number ends in an even number, if the last digit in the number is even, 2, 4, 6, 8, or 0, that there's definitely a factor in 2 in there. So if I was factoring 26, I'd say, oh, it ends with a 6, so I know there's a factor of 2 in there. And then I can check. 2 goes into 2 once. 2 goes into 6 3 times. So the two factors for 26 are 2 and 13. 2 is prime. 13 is also prime. So 26 is 2 times 13. All right, 5s. The residue or fingerprints of a 5 on a number are going to show up in that number ending in a 0 or in a 5. If there's a 0 or 5 is the last digit of that number, I know there's a factor of 5 in there somewhere. This one also has a 0 at the end of the number. So when I'm trying to find the prime factorization of a number that has a 0 at the end, the fastest way to do it is to say it's the non-zero digits times 10, if I have 1 0. If I have 2 zeros, times 10 times 10. So these zeros at the end are factors of 10, right? Because 10 times 25 is 250. So there's a 0 at the end. The first factoring you want to do is to multiply whatever the digits are at the front times 10 for each 0. The bigger the numbers I can break it into, the faster this prime factorization is going to go. Every 10 is a factor of 2 times a factor of 5, both prime. And 25 is a factor of 5 times a factor of 5. So the prime factorization from 25 of 250 is 2 times 5 times 5 times 5. 3 factors of 5 and a factor of 2. One factor that is hard to find unless you know the trick is factors of 3. This number looks prime, and numbers that have factors of 3, if they get kind of big, they often look prime. So the trick to figure out if there's a factor of 3 lurking inside this number is to add up the digits. This only works for 3s and 9s. Don't think that this works for every factor. So if I add up all the digits of my number, 2, 3, and 1, 2 plus 3 plus 1, I get 2 plus 3 is 5 plus 1 is 6. If the sum is divisible by 3, then the original number is divisible by 3. This is one of the most useful things I've ever learned. So 3 goes into 23 7 times, and 3 goes into 21 7 times. So 231 is 3 times 77. 3 is prime. Hopefully you recognize 77 as a factor that has a factor of 11 in it. Anytime you have both digits being the same number, we got 7 times 11. And both 7 and 11 are prime. So 3 times 7 times 11. So that 3 is really hard to spot. Use that trick. Add the digits together. If the sum is divisible by 3, you know 3 goes evenly into that number. Always check. Do that check for 3's before you decide you can't factor any further. All right, even for non-super complicated fractions, I like to simplify them using prime factorization. If the fractions aren't super hard, the prime factorization isn't that hard. And if the fractions are really complicated, then the prime factorization is super useful. And the more you practice, the more you just look at the number and know, and don't have to work out a whole factor tree. So 25, hopefully you know, is 5 times 5. 35 is 7 times 5. And so I didn't need the tree. I knew what each number's factors were. And the more you practice, the more you're going to know those factors and what's in there. And I can see I have a factor of 5 in the numerator and a factor of 5 in the denominator. 5 divided by 5 is 1, so these cancel to 1. Please remember, when you cancel numbers, you're replacing them with a 1. They're not 0, they're not gone, they're replaced with a 1. So my numerator is now 5 times 1, which is 5, and 7 times 1, which is 7. And I don't have to wonder, I don't have to do any more checking. Is there anything else I can divide? If you get all the way down to primes, cancel the factors that are identical in the numerator and denominator, you are absolutely, definitely done. There is no further checking required. All right, let's try it with a harder one. So this one's going to take more effort in the prime factorization, but it would also have taken more effort to simplify it by dividing over and over again. So let's look at 120. It's got that 0 at the end, so I'm going to say that's a 12 and a 10. All 10s are a factor of 5 and a factor of 2. The 12, we could say maybe 6 and 2, and 6 is 2 and 3. So my factors are going to be 2 times 2 times 2 times 3 times 5. Those are my primes. 2 times 2 times 2 times 3 times 5. Make sure you get all your factors in there, and make sure you only take the primes. Take a look. There shouldn't be any 6s, 12s, or 10s in there. You only want the primes. These numbers should all multiply together to give you this number if you've done it right. For 132, I know there's a factor of 2 in there because it ends in a 2. So I can divide 2 into 132. 2 goes into 13 6 times. 2 goes into 12 6 times. So I have 2 and I have 66. The 66 double number, so it's got to be an 11 and a 6. And the 6 is the 2 and the 3. So I have 2 times 2 times 3 times 11 are my prime factors for 132. And now that I have completely broken these numbers down into their primes, I can see what cancels. A 2 divided by 2, I can replace those with a 1. 3 divided by 3, I can replace those with a 1. 2 divided by 2, I can replace those with a 1. So my numerator is 2 times 1 times 1 times 1 times 5, which is 10. And my denominator is 1 times 1 times 1 times 11, which is an 11. I don't have to check any further. If I have canceled every factor that canceled and I went all the way down to primes, there is no way that this number is not completely reduced. Let's do one more. 15, I don't need a factor tree for. I know that's just 3 times 5. 105 is kind of a bigger number. I see the fingerprint of the 5 on there because it ends at the 5. But look at 5 plus 1 is 6. So I know there's a factor of 3 in there as well. 5 goes into 105. It goes into 10 twice. Goes into 5 once. So 105 is 5 times 21. 21 is 7 times 3. There's that 3. I knew it was in there. 3 times 5 times 7. All right. And when I cancel, 3 divided by 3 is 1. 5 divided by 5 is 1. A lot of students forget that when you're canceling, you're replacing the numbers with ones. And when the entire numerator cancels, some students think that they have a 7. Please, please, please don't make that mistake. Your numerator is now 1 times 1, which is 1. And your denominator is 1 times 1 times 7, which is 7. You have 1/7. The factors in the denominator stay in the denominator. If everything in the numerator cancels, what's left in the numerator is a 1. And this number is obviously smaller than 1, quite a bit smaller than 1. There's no way it could equal 7 because the numerator is smaller than the denominator. So the simplification of 15 over 105 is 1 over 7. All right, here's one to try on your own. Find the prime factorization of the numerator, prime factorization of the denominator, cancel the factors that cancel, and see what you got left. Pause the video, give it a try, start it when you're done. All right, so 75, I don't need a factor tree for. 75, I think of 3/4, so that's 3 times 25, and I know 25 is 5 times 5. The more you practice doing prime factorization, the more you'll find the little tricks that make it faster, and the more you'll recognize the prime factors in numbers. 102, you should have seen the fingerprints of a factor of 2 on here because it ends in an even number. When we divide 102 by 2, we get 51. So 2 times 51 is 102. 51 is not prime. Remember your trick. Those factors are the multiples of 3. Tend to look prime, but 5 plus 1 is 6, so you should have known that there was a factor of 3 in there. 51 divided by 3 is 17, so I can replace the 51 with the 3 times 17. So the prime factorization of 102 is 2 times 3 times 17, and you can see we have a factor of 3 in the numerator, a factor of 3 in the denominator. So now my numerator is 2 times 17. 7 times 2 is 14, 2 times 1 is 2 plus 1 is 3, so 34 in the numerator, and the denominator is 5 times 5, which is 25. Don't have to check any other numbers. This one might think you got to run through, check 2, check 3, check 5. You don't. You know it's completely simplified because you took it all the way down to primes and you canceled what canceled. Here's another problem. Try it yourself. All right, 27 I know is 9 times 3. 9 is 3 times 3, so 27 is 3 factors of 3. 81 is 9 times 9. Each 9 is a 3 times 3, so 81 is 4 factors of 3. The more you factor numbers down to their primes, the more you see what they're made of. These are both pure 3s. We got 4 factors of 3 for 81, 3 factors of 3 for 27. Knowing that these numbers only contain factors of 3 is not only useful when we're simplifying fractions, it's great when we're trying to find a common denominator as well. So I know that this 3 divided by this 3 is going to give me a 1. This 3 divided by this 3 is going to give me a 1. This 3 divided by this 3 is going to give me a 1. So my numerator is 1 times 1 times 1, which is 1. And my denominator is 1 times 1 times 1 times 3, which is 3. So this simplifies to 1/3. Give this problem a try. Pause the video, start it back up when you're done. All right, here's 24. 24 is 8 times 3. 3 is prime. 8 is 2 times 4. 2 is prime. 4 is 2 times 2. Do this enough and you will recognize an 8 as 3 factors of 2, which is really useful. It speeds things up when you start memorizing those prime factors. 132, 2 plus 3 is 5 plus 1 is 6. Obviously, it also ends in a 2, but the bigger the number you can divide in, the less long division you'll have to do. So if you can find a bigger number, divide the bigger number in first, and then probably what's left will be small enough that you can divide it without the long division. We hate long division, time consuming. 3 goes into 13 4 times. 4 times 3 is 12. I get 1 left over. Drop down the 2. 3 goes into a 4 times. So 132 is 3 times 44, and 44 I can do without the long division. That's 4 times 11. 4 is 2 times 2. Please make sure you get it all the way down to primes. If you wrote this as 4 times 11 times 3, you would miss that these 2's cancel. You have to get all the way down to prime numbers for this technique to work. Otherwise, you're going to miss factors that would otherwise have canceled. So 2 divided by 2 is 1, 2 divided by 2 is 1, and 3 divided by 3 is 1. So in the numerator, I now have 1 times 1 times 2 times 1, which is 2, and 1 times 1 times 1 times 11, which is 11. So 24 over 132 simplifies to 2 over 11.